All right, welcome. You ever use an AI tool and just stop and wonder, how? How did they even build this thing? It can feel like absolute magic, right? But it's actually a really cool structured process. Today, we're going to pull back that curtain and walk through exactly how an AI goes from just a spark of an idea to a real working product. And we'll be using these incredible handwritten notes as our guide. Let's get into it. Okay, so let's just dive right into the big question. We all have those what-if moments, those little sparks of an idea. But how does one of those thoughts actually become a functioning AI? What's the real journey from a concept in someone's head to a tool that can write an essay, create a piece of art, or even discover a brand new planet? That's the path we're going to follow today. Well, it turns out that pretty much every AI project, whether it's a tiny app on your phone or a massive system analyzing telescope data, follows the same fundamental roadmap. You can think of it as the anatomy of how AI is created, a clear, structured path that takes you from a blank slate all the way to a finished product. And that roadmap? Well, it's got a name, the AI project cycle. It's basically the recipe for building AI. But here's the most important thing to get, and you can see it right here on the slide. It's not a straight line. It's a loop. And why is that? Because building AI is never about getting it perfect on the first try. It's all about building, testing, learning from what went wrong, and constantly making it better. That cycle is everything. So here it is. This is our map for the whole journey. These are the 6 core stages we're going to walk through. We start with the absolute most important step, figuring out what problem we're even trying to solve. Then we'll gather our materials, build the actual engine, test it out, and finally launch it into the world. So let's break this down step by step. All right, let's jump in at the very beginning. Before you can build anything, you need a solid blueprint, right? This first phase is all about laying that critical foundation. And trust me, if you get this part right, every single thing that comes after becomes so much easier. Everything, and I mean everything, starts right here. It's called problem scoping, and it's exactly what it sounds like. Before anyone writes a single line of code, you have to answer a really simple question. What are we actually trying to accomplish here? It's like you wouldn't start a road trip without putting a destination in your GPS, would you? Without it, you're just driving around in circles. And to help figure that out, developers use this really cool tool called the 4Ws Problem Canvas. It looks simple, but it is incredibly powerful. It forces you to answer 4 key questions. Who are we building this for? What is the actual problem we're solving? Where is this solution going to be used? And maybe the most important question of all, why are we even doing this? Answering these things right at the start can save a project from going completely off the rails down the line. And this is a fantastic example of that canvas in action, using a pretty huge goal, finding another Earth. Just look at how this breaks it down. The who, basically all of us, the entire human race. The what, the need to find a new habitable planet. The where, using the resources we already have. And the why, to help ensure the future of civilization. You see how that takes a sci-fi dream and turns it into a clear, actionable project goal. That is the power of a simple framework like this. Okay, so our blueprint is all set. We know what we want to build. Now we need the raw materials. And for any AI, that material is one thing: data, and tons of it. Think about it like this. An AI learns from data in the same way we learn from experience or from reading books. Without that data, an AI is just an empty box. And that leads us right into our second stage: data acquisition. This is the process of going out and gathering all of that data. But it's not just about getting a lot of it. It's about getting good data. The notes here say the data must be dependable and correct, and that is absolutely vital. You've probably heard that old saying, garbage in, garbage out. Well, for AI, that's like the golden rule. If you feed an AI bad, biased data, you are going to get a bad, biased AI. It is that simple. Okay, so we've got our blueprint, we've got our raw materials. Now it's time for the fun part, building the engine. This is where the intelligence in artificial intelligence really starts to come to life. And building that engine, that's a process we call modeling. This is where the magic really seems to happen. Developers create algorithms, which are really just sophisticated sets of instructions that teach the machine how to find hidden patterns and relationships in all that data we collected. The end goal is to build a model that can look at brand new information it's never seen before and make a smart prediction or a decision all on its own. Now, for the longest time, AI was really about analyzing stuff, finding patterns, making predictions. But recently, oh man, there's been a complete revolution. We've moved from AI that just understands information to AI that can actually create it. And that revolution has a name: generative AI. So, what is this stuff exactly? To put it simply, generative AI is a type of AI that can create brand new, totally original content. We're talking text, images, music, code, you name it. It does this by studying just massive amounts of existing data and learning the deep patterns within it. But the key thing is, it doesn't just copy what it's seen, it generates something entirely new. And the ways we're using it, it's already changing everything. I mean, think about it. For language, you've got tools that can help you write an email or even generate computer code from scratch. Visually, it's creating these breathtaking images and videos from just a few words of text. And in the world of audio, it's composing new music and generating incredibly realistic voices. This tech is just exploding everywhere. But of course, you don't just build one of these models and call it a day. You have to test it rigorously. This is the evaluation stage, and it's kind of like a bake-off for AIs. Developers will often train several different models and then pit them against each other to see which one performs the best. It's this super important quality control step to find the absolute best performing model before it ever gets out into the wild. All right, we're on the home stretch now. Let's look at our final section and see how this all comes together. We've built the engine, we've tested it. Now, it's time for launch. But with that launch comes a whole new world of responsibility. And now, the moment of truth: deployment. This is it, launch day. This is when the AI finally leaves the clean, controlled environment of the lab and enters the messy, unpredictable real world. It's the point where all of that hard work, from that initial idea on the 4W canvas to the final battle-tested model, becomes a real product that you and I can actually use. But launching the AI is not the end of the story. In a lot of ways, it's really just the beginning. Because the second that an AI starts interacting with the real world, making decisions that affect real people, we have to start talking about one of the biggest and most important topics in technology today: AI ethics. So, what do we even mean when we say AI ethics? At its core, it's a moral compass. It's a framework designed to help us ask the really hard questions and make sure that the technology we're building is fair, that it's safe, and that it's ultimately a good thing for people. It's all about remembering that there are human beings on the other side of the algorithm. And understanding the risks here is absolutely crucial. These notes point out some of the biggest concerns we're facing. You've got AI bias. If the data we feed it is skewed or unfair, well, the AI's decisions are going to be skewed and unfair too. Then there are massive questions around our privacy and how our personal data gets used. And of course, there's the huge, ongoing conversation about how AI is going to impact jobs and the future of work itself. And all of this, really, it all boils down to the single most important question in this entire field. We are getting incredibly good at making AIs smarter. We're making it faster, more powerful, more capable every single day. But the real challenge, the one that will define our future with this technology, is this: as AI gets smarter, how do we make sure it also stays wise?